Okay, this is differentiation in class practice number 19, where we're still talking about trig derivatives. And this is pretty cool. I wanted to show you this. It says find the 50th derivative of y equals cosine x. So before I start, I'm going to remind you of the trig square that we learned. And the trig square is if I have sine x, the derivative of sine x is going to be cosine x. The derivative of cosine x is going to be negative sine x. The derivative of negative sine x is going to be negative cosine x. The derivative of negative cosine x goes back up to sine x, and then so forth and so forth. So this trig square is going to come in handy with derivatives and antiderivatives as we go along this year. So I want to find the 50th derivative of cosine. So here I'm starting. So if I start the first derivative, it would be here, second, third, fourth, and I could keep counting. But what you can do is, if you'll notice, this square has 4 derivatives in it, or 4 functions, I should say. If I take the 50th derivative and divide it by 4, it goes in 12 times, which means I'm going to go around this square 12 times with a remainder of 2. So if I start at cosine, a remainder of 2, so here's where I started, 1, 2, that means y to the 50th, that's how we write it, so you don't have 50 little lines, is going to equal negative cosine x. So you can actually find any derivative going that way is by going around the square. You could count if you want, but it's easier just to say, okay, I'm going to divide this by 4 and figure out where I'm going to end up. So here's where I started. I have a remainder of 2, 1, 2. So the 50th derivative is negative cosine x. So I love showing that. So that's pretty cool. The other thing I wanted to show you is that you can do something like this, is find the equation of tangent lines to the graph y equals sine x. So the first thing we're going to do is do a nice little sketch of y equals sine x. And I'm going to do it like this. Sine starts at midline. And I didn't go over far enough. Okay, so right here I know is 0. I know here's pi. I know here's 2 pi. And I know it's pi over 2 right here. And 3 pi over 2. So I'm just kind of getting it all marked out for my x-axis. I know it goes up to 1 and down to negative 1. My graph's not very symmetrical, but you guys get the idea. Okay, it says it wants you to find the equation of the tangent line at x equals 0. So they want you to find the tangent line here first. So that's the first tangent line they want us to find. And the other one, they want us to find it at pi over 6. We'll do that one in a minute. So when I go to do this one at 0, the first thing is if it says equation of a tangent line, you guys know you have to write y minus y1 equals mx minus x1. And you know you need to have a point in the slope, okay? Well, the point is going to be 0 something. How do I find the something? Well, you plug the 0 in your original. So I want to do y of 0 is going to be the sine of 0, and the sine of 0 is 0. So I know my point is 0, 0, which makes sense. It's right here on my graph. But I just wanted you to make sure that you knew the point. So now I know I'm going to throw a 0 here, and I'm going to throw a 0 there when I'm done. Now the next thing I need to do is slope, and the slope is going to be the first derivative. So I'm going to do y prime, and the derivative of sine is cosine of x, which is nice. But I have to find the slope at 0, so I'm going to do y prime of 0 equals the cosine of 0, and the cosine of 0 is 1. So I know the slope is 1, so a 1 is going to go in there. So my tangent line is going to be, I'll write it over here, is y minus 0 equals 1 times x minus 0, or x. So it's just 1x, or y equals x. That is the equation of that tangent line. And that makes sense. It kind of looks like it does like that. So that's the equation of my tangent line. Now at pi over 6, whoa, come back. At pi over 6, if you want to think about it, is 30, okay? And this is pi over 2, or 90. So pi over 6 is going to be kind of like in here somewhere. So I'm going to make a little point here. We'll do a different color. We'll pretend pi over 6 is about here. So they're looking for the tangent line like right here now for pi over 6, because this is 90. So pi over 6 is going to be in here somewhere. So here's my point. So I want to find the tangent line there. So I'm going to do y minus y1 equals mx minus x1. I have to find the slope and the point. So let's do the point. The point is going to be pi over 6 something. What is the point? Now remember, this is the graph of sine. So I have to do this y of pi over 6. I want to know, is the sine of pi over 6? And I know the sine of pi over 6 or the sine of 30 is a half. So my point is pi over 6, 1/2. And that looks, my sketch isn't too perfect, but it's not bad. Oh, sorry about that. So it's about a half, looks like it's at a half. So this is the point on my graph. 1/2 is up here, and this is pi over 6. So here's pi over 6, and here's a half, and that's the point, pi over 6, 1/2. Now I need to find the tangent line, but I have to have the slope. So I know that y prime is cosine x. We did that up here. So y prime of pi over 6 is going to be the cosine of pi over 6. And the cosine of 30, or pi over 6, is going to be radical 3 over 2. And this is stuff that I had you memorize. And I know you can do the decimals, but the radical 3 over 2 is much better. So now we're going to throw the point here and here, and we're going to throw radical 3 over 2 in here. So I've got y minus a half equals radical 3 over 2, x minus pi over 6. You're like, wow, radicals and pi and fractions all in one. So I'm going to move this over and say y equals radical 3 over 2, x minus pi over 6. I'm just going to add the 1/2 on the other side, and that would be perfectly fine. So that's going to be the equation of the tangent line that's in blue up here. That's the other one. So I just wanted to show you that you can actually do equations of tangent lines on trig functions as well, and just set it up like this. So this is the end of this video. I hope it helped.